Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to review and to do a revision on what permutation and combination is. Okay, before this we have learned what permutation and combination is. So this is just a quick review of what about these two. Okay. So permutation is an arrangement of object. So permutation is about arrangement of object. So the order is super important. So when we say about permutation, there are a few keywords that you need to understand. Permutation, it involves, if the question asks you about the permutation, so it involves the words arrange. Then it also involves the word numbers or alphabets or code or sitting or books on shelf and vice versa, okay, and other else. Okay, so next one, the multiplication rule. If event A can be happen by m ways and event B can happen in n ways, then the number of ways of event A and B can be happen is m times n ways. Okay, so let's look at the first example. How many ways for Jackson to travel from Butterworth to New York via Kuala Lumpur? So if Jackson is here, so he wanted to go back to New York, but in order to do that, Jackson have to go through Kuala Lumpur first before he's going to New York. Okay, so now we see that there's four mode of transportation from Butterworth to KL. It's either using the train, either using by car, either by bus, or either by flight. So from KL to New York, there's only two ways, by air or by water. So this might be, it's not yacht actually, so it might be cruise or ship. Okay, so this is the first probability. It's either Jackson using train and then to New York he's going by air, by flight, or maybe train and water cruise, and then by car, and then by flight, or car and cruise, bus and flight, and bus and cruise. Probably by both of the mode of transportation is by air, and another one might be air and by cruise. Okay, so there are 8 ways of how Jackson travel from Butterworth to New York. So you just need to multiply this. There are 4 mode of transportation and 2 here. Okay, so you got 8 ways of traveling from Butterworth to New York via Kuala Lumpur. Okay, example 2. Raymond has 3 pairs of shoes and 4 pairs of socks. Find the number of ways to match his socks and shoes. So this is easy. You know that he got 3 pairs of shoes and he also got 4 pairs of shoes. So what you need to do is that the number of ways is 3 times 4, which is equals to 12. So permutation of n different object. Now permutation is an arrangement of objects in a definite order. The number of permutation of n different objects, Pn, is, so here you go, n factorial, this is factorial, is equals to n times n minus 1 times n minus 1, and continue until finally you got times 3 times 2 times 1. So this is the formula. This is a short notes. What is the value if 0 factorial, which is equals to 1 way, only 1 way. Okay, So let's look at the example. Find the number of different permutation of all the letters of the word super. So you see here how many number of letters? So you got 5, right? So what you do is that the solution is, so the number of permutation is 5 factorial, or we can simply say that 1 2 3 4 5, like this, yeah, 1 2 3 4 5, starting with the number 5, because the number of letters in super is 5 times 4 times 3 times 2 times 1. It's decreasing. Okay, so the number of ways is 120 ways. Okay, in how many different ways? Example 4. Can Riyadh arrange his 6 pairs of shoes into a shoe rack? So same goes with the example 3. So you got 6 pairs of shoes. So what you need to do is 6 factorial, right? Okay, so this is actually equals to 6 factorial. So starting with the how many numbers of pair here, so and then it decreasing until it's equal to 1. So that how factorial works. Okay, so it's equals to 720. So if you see your calculator now, you can see the symbol of factorial. You can see the symbol of factorial is when you press shift and then you press x power of -1. There you see on top of it, if you understand that, so you will see x factorial and logic there. So how to get to x factorial? You have to press the button shift and then x power of -1. Then you will get 6 factorial is equals to 720. Okay, so example 5. In how many different ways can 4 people be seated on a bench for a photographic session? So, so we know that it's arranged in a line. So what we need to do is that we know there are 4 people. So this is supposed to be 4, 3, 2, 1, right? So let's look. So the solution. So there are 4 ways. Everyone can be seated here, right? And then if one have been chosen there, then what left? So only 3 left. Okay, so it's either Haikal, Adrian, or Azmina. So one of them have to be seated here, and then left 2. It's either Azmina or Haikal sits here. Okay, if we say that Haikal sits here, then where should Azmina sit? It's supposed to be at the last bench. So 4 times 3 times 2, you should get, this is equals to 24 ways. Okay, so let's look at example. I hope you understand how to do that. So we go to the next one. Permutation of n different objects taken R at a time. So the number of permutation of n different objects taken R at a time, we denote as permutation. Okay, in this case, you can look at your calculator and you can see the button of NPR is at the multiplication button. Okay, so how are you going to use that? It's easy. Okay, later I show you how to use that. Okay, so NPR, N is the number of different object. Okay, and R is the objects taken at a time. Okay, how many you want from example we have in the box we have like 8 balls, so I only want 2 balls. Okay, so it's like 8p 2. Okay, it's like that. So here's the formula. n factorial over n minus r factorial. Okay, next one. Okay, now let's look at this example. How many different three-letter codes can be formed using the letters in the word glide? We only want 3 letters only from the word glide. How many number of letters we have? We have 5 letters, right? We have 5 letters. We only want to choose 3 letters only. So 1, 2, 3. So you can use 5p3, or you can use using the factorial ways. You can take, because it's 5 letters, so we denote this. We write this. The first one is 5, the second one is 4, and the third row is 3. It's the same if you multiply 5 times 4 times 3. It's equally the same with 5p3. Okay, you can use your calculator to get the answer. How? By pushing the button shift. Sorry, let's start with 5 first. And then you push the button shift, and then multiplication. And then you will see 5p, and then you press the button 3. So you get it is equals to 60 ways. Okay, let's look at example 7. In how many ways can a club of 10 members select a president, a vice president, and a secretary, assuming that the same person cannot hold more than one post? So we have 3 positions, right? In this club, we have 3 positions that we want. One is the president, vice president, and then the secretary. So this is super easy as well. So from 10, we only select 3. So 10 times 9 times 8, or this is equals to 10p3. Okay, so there are 720 ways. Okay, 720 ways of assigning a secretary, vice president, and president. So let's look at the next one. Permutation of n different object for given condition. So example 8. Find the number of ways of even number. Okay, so you have to look at the word even number. Okay, the tip is here. Okay, let's read this first. Formed by using the digits 1, 6, 7, and 8 without repetition. So how to make a number? How we know that a number is an even number? Okay, how? If it's even number, the last number, because we have 4 number, right? The last number must be even number. In this case, how many even number we have? So we have 2 even numbers, which is 6 and 8, right? So how to solve this? Okay, so this is the solution. So we got with 1, 6, 7, 8. Okay, so 1, 6, 7, and 8. We have 4 numbers. We want to arrange it to make sure that our number should be an even number. So what we do is that only 6 and 8 should be at the last number. Okay, so if we take 6 or 8, so what's left in the number is 3 numbers, and then it's reducing times 2 times 1 times with only 2 numbers can be put here to make sure that it should be an even number. So 3 times 2 times 1 times 2 equals to 12 ways. In this case, you cannot use NBR, okay? NBR is or you can use factorial. Okay, 3 factorial times 2. Okay, so this is easy equally equals to 12. Okay, now look at number example 9. How many 3-digit numbers less than 500 can be formed from digits 3, 4, and 5 without repetition? 3, 4, 5. So because the question say less than 500, so 5 cannot be put in front. So only two numbers can be put in front, right? What is that number? It's supposed to be 3 and 3 or 4. Okay, so let's look at the solution. So there's only two ways, two numbers that can be put in front, which is number 3 or number 4. So, wait, what's the number just now? 3, 4, 5. Okay, so 3, 4, 5. There's only two numbers that can be put in front. So what's left? Okay, if we take one number, so what's numbers left? So there's only two numbers left, right? So 2 times with 1. So what do we have? 2 times 2 times 1 equals to 4 ways. Okay, example 10. How many 4-letter codes can be formed using the letters in the word values without repetition such that the letters start with a vowel? What is vowel? Vowel is A, U, and E. So, because the question say it should be 4-letter codes, so we have 4 blanks. 4-letter codes. So, there's only 3 number that can be 3 letters that can be put in front, because the question wants a code that start with a vowel at the first one. So it's either A, U, or E. So we pick one to put here. So what's left? So there will be, if we take one, when I write values, if we take one, if we take one E, for example, so if put E here, so what's how many letters left? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have, let's look at example. 5 times 4 times 3. Okay, because only 3 letters that can be put in front. So wait, so because 1, 2, 3, 4, 5, so that's why 5 times 4 times with 3. Okay, so there are 180 ways. So example 11. There are 60 ways of arranging 5 different objects. Taken R at a time. Find the value of R. So now we have the number of ways. We have 5 different objects, but we don't know how many numbers that we pick. So what's the formula? Okay, so the formula is to get the value NPR, so it should be n factorial over n minus r factorial, right? Okay, because we know that it's equals to 60, so we put everything inside the formula. Inside the formula. Okay, so we know it's 5 minus r, and then we take this to the left hand side and 60 to the right hand side. We simplify that, and then 5 factorial is equals to, you can use your calculator to get the answer. 5 factorial is equals to 120. So 120 divided by 60, it should be 2. That's why you got 2 here. Okay, so 5 minus r factorial is equals to 2, or equals to 2 factorial. 2 factorial is equals to 2 as well. So now factorial and factorial can be simplified. So what's left? 5 minus r equals to 2. So r is equals to 3. So that's how you get the solution. So example 12. 4 boys and 2 girls are standing in a row for a photo taking session. Find the number of ways to arrange them if the girls are to be stand together. Now there are 6 students, right? 1, 2, 3, 4, 5, 6. So the question said that numbers of ways to arrange them if the girls are to be stand together. So girls have to be stand together. So we have how many possible solution? So we have 1, they must be together. They might be sit here or here as long as they are together, right? Or here, or here, or here, right? That's some of the possible ways of the girls have to be stand together, right? So because there's 2 girls, so imagine that this is the girls 2. If we pick the first girl, then the second one here. So how many number of ways just now? 1, 2, 3, 4, 5. So let's look at the solution. Okay, now we have 1, 2, 3, 4, 5. It might be they are seated here, might be they sit here together, or here, or here, or here. There are 5 numbers of solution. So for example, if we pick the girls here too, and another one will be here. So what happened to the rest? This will be where the boys stands. So we know that boys, we got 4 boys, so we got 4 factorials. Okay, so yeah, as what you see, for 2 girls standing together, so here are numbers of way they can be seated together, they can stand together, as what I mentioned before. So the rest will be 4 factorial, because how many number of boys can be arranged. Okay, so you will get 2 times 1 times 5. 5 is ways of how the girls stand. Okay, 4 factorial is the number of how the boys arrange. Okay, so there are 240 ways. Okay, example 13. Faiz, Faris, Akmalia, Afika and Jannah are to be seated in a row for a prize giving ceremony. We are still in permutation, okay? In how many ways can they be arranged in a row if the girls and boys are to be seated alternately? So we have 1, 2, 3, 4 and 5. So we have 5 students. So the starting one must be girl. It cannot be boy. Why? Because if we start with boy, what happened? Boy, girl, girl. Because there's only 2 number of boys. And we have 3 girls, right? So it have to be seated alternately. So this can't be happen. So we must start with girl. So what to do is, this is the arrangement. So how many number of girls? 3. So let's keep 3, 2, 1. Okay, so 3 times 2 times 2 times 1 times 1, this is equals to 12 ways. Okay, example 13. How many 5-digit odd numbers, yeah, that are less than 40,000 can be formed from the digits 0, 1, 3, 4, 7 without repetition? 0, 1, 3, 4, 7. Okay, so for this one, 1, 2, 3, 4, 5, the question said that it should be odd numbers. So odd numbers, we know that if it's odd numbers, the numbers at the back must be odd. So what is that? What is the odd number here? It's either 1 or 3 or 7. Okay, so the question wants 5-digit odd numbers that are less than 40,000. So how many numbers of ways that we can get less than 40,000? Can we put 0 in front? No, right? Why? Because if you put 0 in front, then the digits will only got 4 digits only, okay? So there are only 2 numbers that can be filled in front, which is either 1 or 3, right? Okay, so let's look at how we solve this question. So just now what I mentioned is only 1 or 3, right? It's either 1 here, number 1 is in front, or number 3 is at the back. So there's only one possible of number of 1 to be put here, and only one possibility of 3 to put here. So the rest can be shuffled. 3 times 2 times 1. Okay, or we can put number 3 in front, but number 1 at the back. Okay, so the rest will be seated here. Or we can put number 1 or 3, but only 7 at the back. Because just now we want odd numbers, right? It's either number 3 at the back, or number 1 at the back, or number 7 at the back, to make sure that the number that we arrange will be odd numbers. So there are 2 possibilities of 1 and 3, or 3 to be put here, and the rest are the same like others. 3 times 2 times 1. So what are numbers of ways to arrange this? So we have number of ways is equals to 6 times 6. 6 plus 6 plus 12, because or, right? That's why we put plus. Okay, next one. Okay, we have enter combination. Okay, what is combination? Combination is the selection of any object such that the order of the object is not a concern. Okay, so when we talk about combination, so the order is not important. Okay, the order is not of concern or not important at all. The number of combination of R objects chosen from n different objects is, so here's the formula, yeah? Okay. So these are some of the useful tips that you can use while answering combination. NCN is equals to 1, NCO is equals to 1, NCR can be derived from NPR over R factorial, or NCR is equals to NC N minus R. Okay. So let's look at example 14. A committee of 4 members is to be selected from 10 seniors. In how many ways can this be done? So because the question say, I forgot to mention to you that combination must use these words. Choose words, okay, in the questions. It's either the question use the word choose, or the word says that they wanted to build a team or committee, or food, or anything else. Okay? Okay. Oops. Okay, next one. Okay. So let's look at example 14 again. A committee of 4 members is to be selected from 10 senior members. In how many ways can this be done? So the solution is 10C4. So there are 240 ways. So where do you find C, this function NCR? So it's at the division button. Okay, so how to use this? You push the button number 10, and then you push shift and then division, and then you will get C, and then you push the button 4 and then you'll get 210 ways. Okay, example 15. There are 7 questions in the mathematics test paper. Find the number of ways can the 3 questions be chosen. So what to do is that, how many numbers altogether? We have 7. So we only pick the 3. We only choose 3 questions to be answered. Then the solution is 7C3, which is equals to 35 ways. Okay. So a combination of R objects chosen from n different objects for given condition. Let's look. So example 16. Calculate the number of ways in which 8 children can be divided into groups of 3 and 5. So from 8 to 8 children, we want to divide them into 2 groups. It's either they are groups 3, they should be groups in 3, or they should be groups in 5. So what's the solution? So 8C3, we pick only 3 students first, the first group, or n, because we are using all the children's n, or multiplied with 5C5. So we have 56 times 1, so there are 56 ways. Okay, so make sure the value here is equals to 8. 3 plus 5 is equals to 8. That is to confirm that we are using all the children in this case. Example 17. A flower arrangement will be done from 5 tulips and 7 roses. How many combinations can we obtain if an arrangement that consists of 6 flowers must have equal number of both types? So in this case, we want they have the equal number of both types. 5 tulips, 7 roses. Okay, wait. Okay, so we only want to choose 6 flowers, yeah? Arrangement of 6 flowers. So equal number of both types mean that we pick 5 tulips. From 5 tulips, we pick only 3 tulips, and from 7 roses, we pick 3 roses to make it as an arrangement of 6 flowers. So this is what you do. Okay, so question B. Question B said have 2 roses and 4 tulips. So in this case, we want only 2 roses. So 7C2 times with 5C4. Make sure if you plus this together, you should get 6 flowers. Okay, you can use your calculator to get the value. And last one, have more than 3 roses. More than 3 roses. The arrangement should have more than 3 roses. So what we do? 7 roses. We pick more than 3. So we have 4. So times with 5C2. Or because the question said have more than 3 roses, so it's either 4 roses or more. So 7C5, only 1 tulip, or all the arrangement must be roses times 5C0. Okay, that's how you do it. Have more than 3 roses means we have 4 roses but 2 tulips, 5 roses but 1 tulips, or all the arrangement is using all the roses but no tulips, because we only want the arrangement to consist of only 6 flowers, right? So there you go. This is the first question, the second question, and last one. There are 3 groups here. 1, 2, 3. Okay. Now let's look at example number 19. A contingent of 10 athletes is to be selected from 7 boys and 9 girls. Find the number of ways to form the athletes contingent if there are exactly 3 boys in the contingent. For question B, there are not more than 3 girls in the contingent. So, okay, we want to make sure that the contingent is of 10 athletes only, but we have 7 boys and 9 girls. So in this case, we want 10 athletes. So exactly 3 boys, meaning that from 7 boys, we want only 3 boys. If we pick 3 boys only, so the rest should be girls, right? So 9C 7. If you add these two numbers, so you should get 10, right? So this is following the requirement of the contingent. So you can use your calculator to get the answer. So B, there are not more than 3 girls in the contingent. Not more than 3 girls means that the girls cannot be more than 3. So we said that 9C not more than 3, 9C2 times 7. Oh, sorry. Not more than 3. Okay, let's look at the solution. Yeah, 9C3 not more than 3. Okay, times 7C7. So this one plus this one should be 10, not more than 3. So it must be only 3. Okay. Okay. So you should get 84 ways. Okay, this is the first one we do just now. Not more than 3. Not more than 3 girls are chosen. Right. Next one. Okay, I think this will be the last question. Okay, there are 7 blue shirts, red shirts, and 5 black shirts displayed on the rack. Find the number of choices for Nuek to buy 3 shirts if he wants to have at least 1 red color shirts and he wants all the shirts of the same color. Okay. This is quite long, but it's okay, we do it slowly. 7 blue, 3 red, and 5 black. Okay, Nuek only wants to buy 3 shirts. Okay, so he wants at least 1 color shirt, 1 red color shirt. So we see that it can be 1 red, 2 red, or all the numbers of shirt that he chooses, all 3 reds. Okay, red t-shirt. Okay. Okay, so what we do is that this is 7B, 3R, 5B. 7 blue, black, red, 3 red, 5 black, 5 black. Right? 7 blue, right? Okay, so in this case, we pick 1 red because the Nuek only wants at least, right? At least 1 red. So we have at least 1 red. And the next one is both are blue or 1 red, or both of the other 2 t-shirt must be black, or all only 1 red, but another 2 is 1 is blue and 1 is black, or both are reds but 1 is blue, or both t-shirts are red and one is black, or all t-shirt that he picked is all 3 t-shirts are only red color. So no colors other than red. So if you calculate this, you will get 235 ways. Okay, so for question B, okay, he wants all the 3 shirts of the same color. So it's either 7 for B. Let's do this together. 7 CB. 7 C3 or 7 3 C3 or 5 C3. 3 shade of the same color. Okay, so this is from blue. This is for red. This is for black. So they wanted all of the t-shirt that he chose to be the same color. So you should get, take your calculator. So you should get 46 ways. Okay, so that's all.